Hi, I'm Bruce Evans from App Dev Center 1, and I'm here to tell you about some things you can do to improve the speed of your iOS app. We're going to go over some measurement, some tools that we will use to measure, some compiler settings, and then some do's and don'ts in code. Before all that, though, why do we care? As you can see from the green text, users care, and users want your app to be fast. A fast and ugly app will always beat a slow but beautiful app. But why do we want to measure? Well, this is a quote from 1974. Basically, what it says is we don't want to waste our time making fast things faster. We want to make the slow things faster and use that instead. Another reason we want to measure is because we're always data-driven. We need to have data to make our decisions. So, when you're measuring, keep in mind what you are trying to answer. Also make sure you're testing against something. 1 second and 1 second faster are very different things. And make sure you're using instruments and testing on the device. Now, I mentioned instruments. Instruments comes with a lot of different potential. You can measure CPU with the time profiler, GPU with core animation, memory with allocations, and power with energy diagnostics. Sometimes, though, you don't really need all that power, and you can use XCTest instead. XCTest also provides us the ability to automate our tests, so we can keep going. And finally, of course, there's always third-party solutions, from small snippets all the way to full-flavored apps. What you see here is a time profile of the Wikipedia app. It's a free app. As you can see at the top, there's a blue graph. That blue graph is showing us the time profile of the time spent on CPU for the Wikipedia app. The bottom section shows us a call stack. That call stack is using both hide system libraries and invert call tree. What those two do respectively is that it's going to hide the UI kit stuff and the things that we can't change anyway, and it's going to flip the tree so that the heaviest call is at the top. In this case, you can see that the closure and set toolbar hidden animated is our heaviest and longest running process. Now, like I said before, XCTest is a lot more lightweight, and you can see that from this slide. All you need to do is put whatever you're trying to test inside of a self.measure. And Xcode, when you run your tests, will run it a couple times and give you an average score. Once you get a score back, you can actually set a baseline and make it so that your test fails if your app gets too slow or if this specific function is too slow. And in case you for some reason can't do tests or instruments is a little too much, here's an example of a third-party solution. Whatever you need to do, you put inside a measure block, and this will just print out in the debugger how long that's taking. Now, keep in mind, this is not development code, and you shouldn't be using it in your published apps. Now that we've gone over some tips, some ways of measuring, we're going to go over some tips and tricks to make things faster. This is probably what you really came for. First off, we've got compiler settings. Swift has 3 optimization modes: O none, O, and O size. O provides the best performance, while O size gives us better binary size. Similarly, Clang has 7 optimizations. Of these, O3, O fast, and OS are going to give us the best performance, but they have some trade-offs, so you want to test those on your app specifically before you make a decision. Once you have your optimizations in place, you can switch on whole module optimization to help get your optimizations at a higher level. Instead of optimizing a single file, it's going to optimize your entire module. Taking that another step further, we have the LLVM link time optimization. What that does is it takes it even further and provides more optimization at the link time. Now, you're probably getting bored with compiler stuff, so let's get into code. One thing you can do is specialization. As you can see here, we have a will be specialized and a won't be specialized. Just to fit it on the slide, they're in the same file, but let's pretend that won't be specialized is in an outside module. In this case, Will be specialized is going to get a special version of shuffle made specifically for int. Won't be specialized is not going to get that. So when your app is running, will be specialized will be dispatched directly to a shuffle for int, whereas won't be specialized is going to be dispatched to the generic shuffle, and then it'll be dispatched back to Swift or back to string. Similarly, another thing with dispatch is using final and private on your classes. Whole module optimization can actually do this for you, but it's always best to do it when you know that this is going to be final or private. Now, another thing that it's best to do when you know exactly what you're doing is forcing Swift-backed strings and arrays rather than NS-backed. For instance, an array in Swift is either a contiguous array or an NS array. But if you know you're not going to be using Objective-C, you can specifically say that you want to use a contiguous array and get a small performance boost. String is a little trickier, but it's been found that if you just append an empty string to the end of it, it converts it into a Swift string. Similarly, when and how you use copy on write can help your performance as well. In the first calculate function, you'll notice that big struct is copied on value. Every time this function is called, big struct is going to be copied. But let's say that calculate doesn't do any actual changing of big struct. There's no reason to copy it. That's when you can use the second calculate method. What that will do is, since arrays use copy on write, there's no copy because we're not going to write to it. We're just reading to it. In line, we had a simple experiment and found that just changing this gave us 0.4 microseconds. But keep in mind that that's for every call. So that adds up. On the other hand, you do want to capture by value for closures. Let is always going to be captured by value, whereas var requires extra space because it's got to be put on the heap. And that's going to take a little extra time. Finally, it can be tricky, and I definitely don't recommend it, but you can disable automatic reference counting. That will speed up performance, but unless you're doing a game or something of that sort, I would really, really, really not recommend it. Now, you might be saying, hey, there's one other way that speeds up performance that you didn't mention, and that is putting things from the main thread into the background threads. I didn't mention that yet because technically that makes it slower, but it makes it feel faster. That's called perceived performance. The user is going to see your app, and because it's still interactive, they're going to think it's fast. Just keep in mind that you need a 20% improvement, and otherwise the users aren't going to notice at all. But keeping that in mind, you're usually going to hit that mark when you move something into a background thread. In conclusion, measure. Measure before you make your changes, measure after you make your changes, and make sure that the changes you make are actually improving performance and not just a waste of time. That concludes my presentation. Thank you.